All right, we are finishing off our work with solving equations with variables on both sides. So again, just notching it up one more level. So before we work on actually solving, we're going to work at testing out possible solutions like we've done in the past with solving equations. Now there's just a little bit more to it. So our equation is 41 minus 8x equals negative 6x minus 23. And the solution we want to test is x equals negative 9. So we're going to rewrite our equation plugging in negative 9 for x. So we'll get 41, and then we have minus 8 times negative 9, which is going to wind up as plus 72 equals negative 6 times negative 9 is 54 minus 23. So we get 113 on the left and 31 on the right. Those are not equal to each other, so we know that negative 9 is not a solution. All right, number 2 is all you guys. If you need any help, just let your teacher know. So now let's look at actually solving equations with variables on both sides. So again, our directions, like always, are solve each equation and check your solution. So number 1 says 12x minus 28 equals negative 63 plus 7x. So our goal is to get the variables on one side and the constants on the other. So remember, constants are numbers without variables. So we have 12x minus 28 equals negative 63 plus 7x. So I want to try to move this positive 7x over to the other side. So in order to do that, I'm going to subtract 7x from both sides. So 12x minus 7x is 5x. I still have minus 28. On the right side, I have negative 63, but now I've canceled out the 7x. So now if you look at the left side, all my variables are over there. All my x's are on the left side, which means my constants need to go to the right. So this minus 28 has to get moved over, so I'm going to add 28 to both sides. So I'll get 5x equals negative 35. And then my last step to solve for x is to divide by 5. And I'll get x equals negative 7. I need to check my solution. So I'll do 12 times negative 7 minus 28 equals negative 63 plus 7 times negative 7. 12 times negative 7 is negative 84 minus 28 equals negative 63 plus 7 times negative 7, which is negative 49. On both sides, when I put those together, I wind up with negative 112, so I'm good to go. Looking at number 2, I'm going to rewrite it over here just so I have some more room. First thing I need to do is the distributive property. So 3 times negative 2x is negative 6x. 3 times 5 is 15. And now I can go ahead and work on moving variables to one side and constants to the other. Now, on the first one, I subtracted 7x from both sides. I also could have subtracted 12x from both sides. I just wanted to work with positive coefficients. So in this case, I have negative 6x on the left and negative 4x on the right. So I need to pick one to add to both sides. I'm going to add 6x to both sides because when I work that out, I'll be left with a positive coefficient. If I wanted to, I could have added 4x to both sides, but I would have wound up with a negative 2 over on the left. Since I put my variables on the right, I need to put my constants on the left. 15 minus 11 is 4. 4 equals 2x. So my last step is to divide by 2, and I'll get 2 equals x. And then again, like always, I could plug that back in to check the solution. I'm going to leave number 3 for you guys because I think 4 is a little bit harder, so I'm going to go over number 4. So I'm going to write it out. Negative 9x plus 15 equals negative 22 minus 4 times the quantity x plus 12. First step is distributive property. So when I rewrite this, I like to say that I'm doing negative 4 times x, so that's minus 4x. Negative 4 times 12, which is minus 48. Now, I'm not quite in a spot where I can worry about my variables because if you look on the right side I have like terms. So I'm going to put, I'll have negative 4x, and I'll put negative 2 and negative 48 together, and that will give me negative 70. Now at this point, I can worry about moving x's over. I'm going to add 9x to both sides. Again, I'm doing this because I want to wind up with a positive coefficient. If I wanted to, I could have added 4x to both sides, but I would have wound up with negative 5 on the left. So I added 9x to both sides. Now I can add 70 to both sides, so I'll move all the constants over to the left. 85 equals 5x. And then my last step is divide by 5 on both sides, and I will wind up with 17 equals x. All right, like I said, number 3 is for you guys to do, and you need to make sure you do the check step on all of these to make sure they are right. On the back side, there are 2 types of special solutions we need to look at. So I'm going to work both of these out for you just so I can explain to you what we mean by that. So on the first one, I need to do the distributive property on both sides before I can do anything else. So negative 6 times 4x is negative 24x. Negative 6 times 3 is negative 18. On the right side, 6 times negative 4x is negative 24x. 6 times negative 3 is negative 18. If you stop and look right now, you can see that these are exactly the same on both sides of the equal sign. If you see this, you can stop working because your answer is all numbers. What that means is you could pick any number you want, plug it in for x, and will wind up the same on both sides. It would be a solution. So if you get an equation that you work out, it's exactly the same on both sides. Just stop. The answer is all numbers. Now for number 2, it's a little bit different. Again, I need to distribute before I do anything else. So I have negative 24x minus 33 equals negative 24x minus 78. So if you look at these, they both have negative 24x, but they're not exactly the same on both sides. So I need to go ahead and solve them. So, and at this point, I would want to add 24x to both sides because I'm trying to move the variables over to one side. But what you'll notice is on both sides, the x is going to get canceled out. So I'll just have negative 33 on the left, and I'll just have negative 78 on the right. I don't have any x's left, so I'm done there. Now, it says negative 33 equals negative 78. We know from our practice with testing solutions that this is not a solution. So our answer to this one would be no solution. What that means is you could plug in anything for x and you would not be able to get it to be equal on both sides. So number 1 is where anything will work. Number 2 is where nothing will work. If you have some questions on those because they're tricky, feel free to just ask your teacher. All right, and then lastly, we've got some word problems. So it says write the verbal sentence as an equation, then solve the equation. So we have 9 plus 2 times a number, I'll just put n for number, is equal to 2 less than 3 times the number. So that's 3 times the number minus 2. So that's what my equation is. Now I need to solve it. So I want to get all of my variables, all my n's on one side. I'm going to subtract 2n from both sides. I'll get 9 equals n minus 2. Again, I could have subtracted 3n for both sides, but I wound up with a negative for the n. Now I can add 2 to both sides, and I'll get 11 equals n. On the next one, it says find the perimeter of a square. So the perimeter for a square is just 4 times the side length, because what we know about a square is that all of the sides are the same. Now, if I just did 4 times 2x or 4 times x plus 4, I would just wind up with 8x or something like that as my answer. What we need to remember is that the sides are the same length. So we need to start by setting them equal to each other. So I can set 2x equal to x plus 4 because they're the same length. Now I can solve by x by subtracting x on both sides, and I'll wind up with x equals 4. Now the question says find the perimeter. My perimeter is not 4. I need to plug that in for my side length, so I'll do 4 times 4 I can see that the perimeter is 16. And I'll write 16 units because I don't have a unit there. All right, that's all the new material for Unit 4, Section 3. You do have some review problems that are just solving one-step equations, so that's going back to Unit 3. And then on the last page, there's a word problem for you to work to that's going to wind up being a two-step equation. So make sure you complete those review problems as well. As always, just ask questions if you have them. And that's all for the Unit 4, Section 3 video.